All right, this is Precalculus. We're in chapter 14, limits and continuity. And in lesson 1 on page 909, we are going to talk about limits of a function. What is a limit? Here's what a limit is. Okay? A limit asks, when x is a certain number, value, what on that graph, what value is y approaching from the left and from the right? That's what a limit asks. All right? When x is a specific number, what is the value of y approaching from the left and the right? All right, so if you graph the formula, the function on the bottom of page 909, it looks like this. All right? Grab that, Leah, or hand it back to her. All right?
Ours look different.
So, if you graph all right, at what point is this function undefined? When x equals 4. Because a function is always undefined when the denominator equals 0. So, what we ask in calculus is, okay, in your image that you graphed, I don't know, it looks something like this, huh? I don't know, something like that, similar, okay? It's a 4th degree, so logically it has to keep going here and come back up, because that's what a 4th degree would look like. Are y'all remembering all of those?
Oh gosh.
Been a while, been a minute, huh? All right, but somewhere here where x is 4, you don't see a hole in the graph, but there's a hole in the graph. But if on your calculator you hit table, and it gives you x values and the y values. Do you see that?
Where's table?
Top right, I believe.
Oh wow. Yeah.
Yeah. Table.
Error for 4.
Okay.
Where
If
did
you
you
go,
four?
you got to go all the way back up to 4. Go where x is 4. Go way. You got a long ways to go. Where x is 4, you should see an error. It's right. Do you see error?
Yep.
Okay. Now, if you go back to the graph,
Mine doesn't.
okay, it should. All right, let's keep going. If you go back to the graph and you hit trace, if you hit trace, your marker will be on the graph somewhere. If you go left, look, ladies and gentlemen, that's right. If your marker's over here, go right. If your marker's over there, go left. And as you approach, when you hit trace, your marker stays on the curve. And you can approach 4. We could ask ourselves, if 4 was in the domain, see 4's not in the domain, but what is the behavior of the graph around 4? So, this is what a limit asks. As x approaches 4, where we know it's undefined, what value is y approaching? That's all a limit asks. In this case, what it's asking, it's undefined. Sometimes it's in the domain. Sometimes we're asking for the limit of a number that is actually in the domain. But in this case, we're not. Okay? So we would want to know all around where x is 4, what's the value of y? Well, you could use a table and say, here would be 4. And we go numbers on both sides. And we can say, what's the value of x? What's the value of f of x? And we could plug in numbers. So just to the left of 4, because we know it's undefined here, just to the left of 4, we could say, when I substitute 3.99 in, what is the output? Actually, they do 3.999. We'll do exactly what the book says. Because it's, all right. And you see right here, I'm getting the numbers from this table.
Oh, yeah.
Right here. And they plug in 3.999 for x, and they get the value of y is 1.9984. Then they go back down a little bit further, 3.99. And you get 1.9841. Then they go to 3.9, and you get 1.8479. So you go just below 4. And then you go just above 4. So maybe 4.001, is that what they did? Yes. And you get 2.0016 for my y value. When you do 4.01, you get 2.0161. And when you input 4.1 into plugging it into this equation, all right, you get 2.168. So, from the left, we're getting closer and closer to what number? 2. So from the left, we're getting close to y equals 2. From the right, we're also getting closer to y equals 2. So if I wrote the problem, and this is the function, I could say the limit as x approaches 4 of that function is 2. Got it? What does that tell me? I don't know what y is when x is 4 because it's undefined. But graphically, I can tell what value y is approaching as it gets closer and closer to 4. That's all a limit tells us, all right? Yes?
So whenever you put that in your calculator, you just like go to the side until you see that it's like surpassed 4? Like once the number that like you're inching towards is bigger than 4, then you know that like you need to go back and see what the limit is?
Yes. And actually, you could fix your table. Well, we're going to literally plug these numbers in to equations. All right? That's what we're going to do.
So you can't like go on the graph and look at the numbers on both sides, like, because it's like 3.9 and 4.1. You can't like look at the number that fall like.
So this chapter, y'all know my preference is always the algebra. That's lesson 2. This chapter is all looking at your calculator. But that's why I did this, because this is focused more on the algebra as opposed to looking on a calculator and seeing where it's approaching. This is always more accurate. Okay? All right, so 2 represents the limit. It's the limit. You got it? This is how you set up a limit equation. Now, what if I said, now my f of x is 2x plus 1. That's my function. Okay? And I want to know the limit of that function as x approaches 1. The first thing I here was 4 in the domain.
No.
So I have to do this because 4 is not in the domain because it's undefined. 4 makes this undefined. You got it? I can still have a limit even though it's undefined. Is 1 in the domain of this function? Is 1 in the domain of this function? What is that question asking? When I substitute 1 in, do I get a y value? Is 1 in the domain? Because remember, it's in the domain if as long as it's defined.
Mm-hmm. And if you
So is 1 make this defined? Yes. So how do I find the limit, do you think? Plug it in for x. What's the limit?
Really? Oh yeah, because it's just the y.
Because what does the limit ask? As x approaches 1 for this function,
What is y doing?
what is y approaching? And we know because it's defined in the function. Make sense? Okay, here is an instance of when a limit can be reached. A limit can be reached when it is defined. Here is an instance that it just gives us the idea of what y is approaching. The limit is never reached because it is undefined. All right, look at example 1. Y'all hang with me. Look at example 1. Okay, we're going to do this one in our calculators. Okay? Set your calculators in radian mode. So y'all going to help me with this. All right? Look at this function. All right, and it wants us to find the limit as x approaches 0 of that function. Okay, the first thing we ask is 0 in the domain?
No.
Why?
Because 0 can't be in the denominator.
Because 0 can't be in the denominator. So if I build a table like this, where 0 is in the middle, I'm going to go a little bit to the left and a little bit to the right. I'm going to substitute those values in for x. I'm going to solve for y. All right, are y'all in radians? Make sure you're in radians. All right, it's easy going up. Going up for x is like 0.001. 0.01. 0.1. All right. Going down is the negatives. Negative 0.001. Negative 0.01. Negative 0.1. Okay. In this function, I need somebody to substitute this in and get y. Who will do this one? Emma, who will do this one?
I'm confused.
We're substituting these values in for x here and here.
Do we have to do it in our calculator?
You have to do it in your calculators. Yes.
Like just We're not graphing.
Okay, we're not graphing.
Okay.
Okay, who wants to do negative 0.01? All right, Beckett, Lydia, negative 0.001. Who will do 0.001?
I'll do it.
Leah, 0.01. Hannah, did you do one? 0.01.
You just plug this number.
Emma, you go do 0.1 as well.
Okay. Sign X over.
I think that's our calculator. Okay. And we're going to see what it's approaching. Actually, I can probably do it.
Miss Haley,
Yes.
will you come see so I can ask you a question?
Yes.
So type in graph it and then do trace.
Yeah, I got it.
I got
one. Can we just do this instead of like plugging in? 'Cause
You,
that's
you
the same
can.
number.
Yes, you can.
Okay.
Yes.
Because that makes it way easier than like
Okay.
because I normally make some mistakes with the
Give me your
other.
calculator. All right, everybody look. Everybody look. If you graph it, ours you're not going to have to graph, but if you graph it, this might be helpful with your homework. If you do trace, and let's say our x value, wait, maybe I need to be out of that.
You just click trace and then put the number in.
And then let's say negative 0.1 and enter. It gives you the y number, gives you the y value.
Whoa.
Okay? All right. So, negative 0.1 is what?
0.9983.
Who has negative 0.01?
Wait, negative point.
01.
Oh.
What is it?
0.9983.
Okay. Who has negative 0.001? What?
0.999999.
There we go. Who has 0.001?
Me.
What is it?
0.9999. It goes on and on.
Okay. Who has 0.01? Yes.
It was 0.9999.
Okay. Who has 0.1? Yep.
0.9983.
Okay. Everybody look. What is the value approaching from the left? 1. What is the value approaching from the right?
1.
So what's the limit of that function?
1.
Is it defined? No. But does it have a limit? Yes. It tells us graphically what value y is approaching as x is approaching 0. Make sense? Got it? Okay. Now, let's look at example 2. It's a piecewise function.
Oh, I hate that one.
It's okay. You just have to think logically. It's not a bad one. It's not a bad one. Glad I filled my squirter bottle up and never finished it. Never finished it. Okay. Yeah, mostly water. All right. Just makes it so much easier to wipe clean. All right. Let's get all of this wiped off. I'll be spending most of my time wiping the board, huh? All right, look at the next example. All right. All right, here's the function. All right, so that says y equals 0 when x is an integer, a whole number. Got it? And y is 1 all the other times. All right? So if we were to graph this, 1, 2, it would be, it's 0 when it's an integer, but it's 1 every other place.
Wait, what's
I don't understand.
that says x equals. No, is that
F of x equals 0. That's y. That's the same thing as
No,
y.
I mean the
Integer. That's the symbol for integer. X is anything else. Got it? Anything else other than an integer? All right? Now, tell me what a limit asks. Micah, what does a limit ask?
The limit asks for the limit of function is it was the limit of the as x approaches the undefined.
Or a number. It
Or
doesn't
a
have to
number.
be undefined.
As approaches the undefined.
A number.
Y approaches its limits.
What is y approaching? Yes, say it.
The limit asks as x is approaching a certain number, what is y approaching?
Correct. Good job. Okay.
Okay.
Okay, so this is the function. This is the function. So what's the limit of f of x, this function, as x approaches 2? All right, so as we approach 2 from the left, what value is it approaching?
One.
It's approaching 1.
Wait, I can't really.
I know, I should have drawn it bigger.
Oh, okay. I kind of see what's going on.
Oh, because it's no integers.
Is anything else?
Got it? That's the graph.
Okay.
All right, so from the left on this graph, as we are approaching 2, what value is y approaching?
Mm.
From the left, what value is y approaching? So what's the limit? So we've looked at 3 different types of situations. We've looked at 2, where what we're asking x approaching is not defined. So we're looking from the left and the right, right? It's not defined. We looked at the 2x plus 1 function, and it is defined. So from the left and the right, it's approaching the limit as x approached 1 of 2x plus 1 equals what f of 1 was. Got it? In this case, the limit as x approaches 2 of f of x does not equal f of 2. So the limit does not always equal what when we substitute that value in, because what does a limit ask? A limit doesn't ask what's the value of y when x is this number. It asks
What is approaching?
what is it approaching from the left and the right. Got it? Okay. Y'all hanging with me?
Yes, ma'am.
Okay. All right. Now, let's look at example 3 on the top of page 913. Okay, y'all have to dig deep, because our f of x is sine squared pi x minus cosine pi x. So you'll have to dig back into trig. Trig is very much a part of calculus. 0.5 is 1/2. right? So when x is 1/2, what is y? All right, so here's my f of x. It's sine squared pi x minus cosine pi x. And we want to know the limit as x approaches 0.5 of that function. All right, is 0.5 in the domain?
I'm not sure. Is it? Should we put it in our calculator?
What's the domain of the sign for x values?
0 to 9.
Oh.
0 to 5.
Oh gosh, I'm getting PTSD.
What's the domain?
Infinite.
Oh.
All reals.
All reals.
What's the domain of cosine?
Reals.
All reals. So is 0.5 in the domain?
Yes.
Yes. So it's going to equal the sine squared of pi over 2. That's substituting a half in for that. Got it?
Got it.
Minus the cosine of pi over 2. I don't think that one was squared. No, it wasn't squared. Okay. What is... Okay, y'all, remember? This is pi over 2.
Yeah.
Cosine starts at 1. Sine starts at 0. Cosine counts down to
2, 0.
0. Sine counts up to...
1.
Okay, so, all right, here we go.
First quadrant. Hey.
All right, so what's pi over 2? What's the sine of pi over 2? People, we just said it.
Oh,
1.
1. What's 1 squared?
1.
1. What's the cosine?
0.
Minus 0.
It's 1.
So it's 1. So what's the limit? Because it was in the domain, we just substituted it in. Got it? All right, turn to page 914. There are 3 cases when a limit does not exist. However, I'm going to go ahead and give you this caveat. Listen, however, we're going to look at 2 of these situations, and we are going to use limits to describe the behavior of the graph. So although a limit doesn't exist for 2 of them, we will use it in 4 or 5, lesson 4 or 5, to talk about what is the behavior of the graph. What's it approaching? Positive or negative infinity? All right, so the first one is if a function gets infinitely larger or infinitely smaller as it approaches that value. So I'm going to draw an example of that. An example would be 1 over x. I don't know. Okay, no, example 4. They gave you 1 over x squared. It doesn't matter. 1 over x is the same. Well, 1 over x squared would be different. Let's do 1 over x squared. And then we'll do 1 over x maybe. Okay. So, if f of x equals 1 over x squared, and we want to know the limit as x approaches 0. All right, we know it's undefined. There's no limit, but why? All right, as x gets closer and closer to 0, y'all reason with me. As x gets big, what happens to y?
Smaller.
Smaller. Does it matter if it's positive or negative? Because it's squared. So as x is a big negative or a big positive, this number gets smaller. As x gets smaller negative or smaller positive, what happens?
When it gets
You're
bigger.
bigger.
Because it's getting
Yeah. All right. So the graph it gets positive, Paula.
So is it getting closer?
So from the left and from the right, it's approaching infinity. Infinity. Get it? Y is approaching infinity. So when from the left or the right, Y is approaching positive infinity or negative infinity. It doesn't matter. They're both approaching negative infinity. There's no limit. No limit. A limit does not exist. Are we going to use limits to talk about behavior of graphs? Yes, we will. But there's no limit.
How do you get curves? Like, how come it doesn't stop at 0?
Okay, we just said, as x gets bigger negative, bigger positive, y, it gets smaller and smaller. It gets closer and closer to the x-axis. As the numbers get smaller, y grows.
Okay, that makes sense.
Okay, because like 1 over 100 squared is a very small number. But 1 over 0.001 squared is a much bigger number.
So when it's 1 over x squared, it does this?
Yeah. Yeah. All right. Now, there's another case when we just have this. From the left, it's approaching positive infinity, and from the right, it's approaching negative infinity. They're opposites. There's no limit. A limit does not exist because they're approaching different values from the left and the right. All right. Also, here's no limit. I'm just going to make a curve. Okay, as x approaches 0, is it approaching the same, is y approaching the same value from the left and the right? No. Micah.
X is approaching
Micah. No, you were sleeping. Wake up. Listen, I want you to stand up, drink water, do what you have to do. From the left, it's approaching a negative number. From the right, it's approaching a positive number. When from the left and the right, as x approaches that value, y is approaching different values, there's no limit. A limit does not exist. So, positive, positive infinity, negative, negative infinity, positive, negative, any infinities involved,
No.
limit doesn't exist. Approaching different values from the left and the right, a limit does not exist. So 1, 2, the third situation where a limit does not exist is when it oscillates very close. So when the curve oscillates, well, it's not really approaching a value, right?
Right.
It's wiggle worm. Got it? All right.